All right. So in the previous lecture, we talked about the client side. We talked about how to compile F# to JavaScript using Fable, and we saw that we could basically any place where we would normally write JavaScript, we could instead write F#, and then just you compile it or transpile it to JavaScript and send and then use it in place of handwritten JavaScript. Then we looked at Fable Elmish, which provides a model view update framework for the Fable compiler, which allowed us to do nice reactive web applications. And we also looked briefly at Bulma, which adds nice styling and automatically make our web page responsive so that they will work nicely on mobile phones and all kinds of devices and different screen sizes. So, but we didn't have a server. So this is the topic of today. We're going to look at the server side of things. Now, this is in principle pretty straightforward. Once you get the hang of this is really not too difficult. But as usual, there are certain things that you need to know, or it's very helpful to know. So I thought it would be good to review a little bit sort of where we are. So back in the days, the typical way things worked was that you had a web server which ran some web application, and your browser would send a request to the server requesting some certain page, maybe post some payload, and the server would generate a new HTML payload and send it back to the browser, which would show it. And as soon as you clicked on something, it would send a new request to the server, and the server would update the state and then render a new page and send it back to the browser. And that was how it worked. And then JavaScript came along, Ajax came along, HTML5 came along, and the trend has been transitioning from web pages to web applications, which means that the client will load a tiny little HTML snippet just to bootstrap the whole thing. It will download a JavaScript application, which will then take over the browser page and generate the app and do all the interactions. Now, these two ways of doing things are very fundamentally different, but they are complementary. It's still perfectly valid to have traditional web servers serving web pages. It's absolutely perfect for a lot of cases, but it's not really good for other types of applications. Like if you would have to reload everything every time you click on an email in Gmail, it wouldn't be very nice. Or if you would try to implement Word in the browser, it would suck pretty terribly. So these are two different ways of doing things. And we have been looking at how to write web applications using Fable. Now, there's still sort of a hybrid between these two, because sometimes you have clients, maybe there's some heavy processing involved that you don't want to give to the clients. Maybe your clients are have very scarce resources. They run on some really low power processor and have very little memory. Then you can still do sort of a hybrid version where you in principle have an app, but the rendering is happening server side. This is stuff that people who are doing Blazor are working on. Blazor is a WebAssembly framework that Microsoft has worked on. So this is sort of interesting development. Then there's a different thing again, because back in the day it used to be that you installed a web server, HTTPD, some sort. That would be Apache or Nginx or some other web server, and then you would configure that web server to interact with your web application or tell it where to find your web pages and the JavaScript, and it would, as a request would come in, it would just send that stuff over to the client and it would handle all the traffic. So this is the sort of hosted version of a web application. what we are going to be looking at today is unhosted. That means that the web server is actually a library that we compile into our application. And this gives us a lot of flexibility. First of all, we don't need to carry around all kinds of complicated garbage that we don't need inside the web server. We can focus on the essence of things, and it also gives us a great deal of flexibility of how we want to set things up. So this is how we're gonna be doing web applications today. So in this overview, I'm gonna be very I'm gonna tell you a little bit what's out there. You can Google, you can explore, but then I'm gonna focus on how we are doing things at work, and why we're doing it the way we're doing it. So this is kind of opinionated, this presentation. And I'm not going to tell you very much about this. There's great documentation. You can Google, you can search. But the most important thing is to have a general idea of what is really going on when you build web services, server-side services. So, in principle, this is simple. So this is the anatomy of a web service. And we can, as functional programmers, this is really quite simple to sort of split up, and we can make a nice design of it. And the way it works is that we have some sort of web server. It's a thing that has the right permissions for the operating system, and it opens up some port, maybe port 80 or 8085 or 8080 or whatever it is, and it sits there and it listens on a network port, and in comes a request. And now I see that the arrow is pointing the wrong way. It should be pointing that way. In comes a request. It comes with a HTTP protocol, and the web server will simply just get the raw data off the wire and wrap it up in something we will call the context. And sort of mentally we can think of the context as just a record type or a huge tuple or something. It just contains stuff like the root, who asked, return address, and request, what was the request, and we can add the response to it. There are headers, and so on and so on and so on, authentication things. Now, and the whole thing after this is really just a function that we can mentally compose as a pipeline. So we take this context and we feed it into some processing unit. So here I, for example, have added a authentication thing. It will take the context, it will maybe do IO, maybe check some databases, maybe it will contact Facebook or Google and do single sign-on and do whatever it might be. But the end result of it will be an updated context thing that it can send on to the next part of this pipeline. And here I've added something that would check whether the root that this request was, if it was requesting a static file, and then it will go to the file system and pick up that and add that to the response. Then maybe pass on the new context that it generated to some session management, for example, and then I passed it into Giraffe, which we will talk about a little bit later, which is a sort of functional framework for building web services. Very nice to work with. And then in the end, it will take this context and give it back to the web server, and it will wrap it up into the right protocol thing and send it off as a response to whoever requested it. Now, of course, the whole pipeline here needs to be asynchronous, because we don't want the HTTP server to block while we're processing. That would be really bad, because maybe it takes 5 seconds or 10 seconds for this thing to do all the authentication and databases and what have you, and then if everybody else would have to queue up, that would be a bad thing. Also, so all these green boxes might find that they need to do things asynchronously. So then it's really good to have everything inside this async, in an async block, because then we can also do things in parallel and so on. So if we were to just type this up in terms of F# and see how could we represent this pipeline in some in some functional form so that we could program these pieces. I always found previously when working with Apache and working with Python web servers and what have you, I always found web services immensely complicated. There were so many bells and whistles, but having this functional pipeline mental picture in your head, I think is really great, because it makes it quite easy to think about these things. And it's really, we'll see, this is exactly how it works, also in practice. Although there were going to be slight variations to the themes for various reasons, which I will mention later. Now, here's the functional pipeline. And first we define a new type, which is called HTTP context. It's just a record type. In reality, this will not be just a record type. It will be some sort of object with some methods on it, or static methods on it. But it's pretty much, we can just think of it as a record type. And in certain implementations, it is actually a record type. Then we have some sort of result. And as you remember, the whole thing was supposed to be asynchronous. So this is sort of what comes out of a block. And it needs to be asynchronous, and it produces a new context, but it might also fail. So that's why we have this option here, so that we give us the opportunity to shortcut things, because there was failure. So that's a slight little complication that we add to this. And then we can define a HTTP function. It takes a context. So this is HTTP function here is a one piece of your pipeline. So you would just say, okay, this is a function for processing HTTP contexts and produce results. And it takes a context and produces a HTTP func result. And now this is not a functor or a monad, in the sense that there's really no generic parameter here, but we can use the same ideas and the same machinery, although we don't have a sort of a free parameter in it. So we can define something which resembles bind, which takes from one end of the pipeline. So this is like the normal functional pipe that we use all the time. So it takes the result of the previous piece in the pipeline. It takes a function and it picks out the stuff inside of this one, lets this one apply on it, and produces a new result. And then we can just pipe these things one after another. We can also do the other one, which is the fishbone version, or the sort of Kleisli arrow version of it, where we just say, okay, let's just compose these functions, and then we'll just feed in the context in the end. So then it's just the HTTP func and a func, and it produces a new func, normal function composition. And this is it. This is really how simple it really is, and you can really implement the whole functional web service pipeline like this, and it has been done. There is a really nice web server library for F# called Suave, which does it exactly like this. So, but we're not going to use Suave. So in this like at work and in this lecture, we're going to be looking at two things. We're going to be looking at ASP.NET Core, and if anybody of you know ASP.NET from before Microsoft technology, ASP.NET Core is something completely different. I don't think there's a line of common code between classical ASP.NET and ASP.NET Core. It's totally redesigned, and yeah, we'll get to see more of it. And then we're going to be using Giraffe, which is a framework for building web services on top of ASP.NET Core. And Giraffe, again, was heavily inspired by Suave, which came first. And Suave, again, was heavily inspired by several implementations in Haskell, which used the exact same pipeline thinking. I will mention it here. There's also a library called Saturn, which is heavily inspired by a web framework called Phoenix, which is running on the Erlang virtual machine and the Elixir language. And Saturn picks a lot of stuff there. Saturn also uses ASP.NET Core in the background. So Suave is the only one over here which is not dependent on ASP.NET Core. But we're going to be looking at raw ASP.NET Core, and we're going to be looking at Giraffe on top of that. The reason we're not looking at Saturn is that Saturn is actually quite nice, but I find that it sort of obscures things, and using ASP.NET Core directly makes it easy to Google things on Stack Overflow, and you can pretty much translate the C# example straight into F#, and you're up and going. Because things tend to get a little bit sort of messy in practice, and you don't really want to know all the details about everything. So then it's good to just be able to copy paste stuff from Stack Overflow. We're going to need some communication. We're going to need some client-server communication. We're going to need server-client communication, and we're going to need sometimes also server-server communication. I'm not going to talk about server-server communication. There's plenty of stuff in .NET for doing that. But we're going to be using this thoth that we looked at in the previous lecture, which also has a server-side component. It comes with this thoth JSON and thoth fetch. And on server side, we're only going to be concerned with the thoth JSON serialization. There's also a library which is nice, which is called Fable Remoting. It makes sort of a remote procedure call like interface on top of things. Again, we don't use it because I think it obscures things. Also because in the end, the amount of time you spend mucking with these sort of server, the sort of interface between the server and your application and the ASP and so on is minimal. Like it's maybe a few % of your time is going to be spent there, maybe less. So I don't really, I just keep it super primitive, super simple. I have complete control over what's going on, and I don't need to hide anything. So that's my personal take on this. There's also something called Elmer's Bridge, which is kind of interesting. It sort of sets up this model view update setup for the server side as well, so that you have and for the communication, so that you can program both the server, your client, and all the communication. Everything is done with the same sort of model view update message passing scheme, which probably can be quite nice. I haven't tried it, but interesting. So, why ASP.NET Core? So there's a number of reasons for this. First of all, it's ultra performant, and this may or may not be very important to you, but in general, it's kind of important. If we sort of have web services that we're expecting to get like 10,000, 20,000, 30,000 hits per second, you want something that performs and which it's very little memory and is able to keep the load up. It comes with a huge number of components or middleware that you can plug in, and all kinds of configurations. So you get loads of stuff for free. Now this is also true of other libraries, of course, but ASP.NET Core really there's a lot to leverage there. It runs on Kestrel, which is this web server library that we use, or you can run it on top of IIS if you're on a Windows platform and need to have it hosted. So it sort of fits in on both worlds nicely. Another reason why one might want to use it. And it's supported by Microsoft. So the whole and it sits so nicely and naturally with the whole rest of the .NET framework and everything. So this is the framework that is around automatically when you install stuff on .NET. So this is what we're going to be using. Now, ASP.NET Core it's not the nicest of things. It's not too bad when you know what you're doing. It's ultra object-oriented in its design, and it uses a lot of object-oriented techniques, modern object-oriented techniques to do the stuff. Delegates and build-up patterns and middleware and dependency injection and blah blah blah. all kinds of things. And for somebody coming from the functional world and who never really was interested in sort of those things from the object-oriented perspective, I must say, when I hit ASP.NET Core myself, I struggled. So that's why I want to give you a little bit of introduction to how this works, my understanding of how things work, because it really makes it a good deal easier to work with when you understand how things are, because this is speaking a different language than the natural functional language that we are fond of and used to. So if we go back, continuations here, the last line, we'll start with that one. So let's have a look. So the thing is, we want to create a pipeline of various components, of these middleware components, or these processing units. We would just call them functions. Microsoft and the object-oriented people call them middleware, because of course a function is too simple. It needs to be something complicated. So then they have these middleware things. But when you start composing these things, it's a async with some context object in an option, and every time you bind to sort of get the stuff out from the previous result, from previous computation into the next one, there's a lot of wrapping, unwrapping going on, and a lot of the time this is unnecessary, because it might be that the stuff that you're actually doing isn't asynchronous and it doesn't have to do all this stuff. So then you're doing a lot of unnecessary work, and this is suboptimal for performance. The other thing is that you're going to get loads and loads and loads of small function calls. And of course, every time you call a function and that function calls a function, calls a function, calls a function, calls a function, everything gets pushed on the stack, and the stack grows, and you get like pretty big stack pressure on things, because these pipelines can and will get pretty sort of long at times. So then the ASP.NET Core people, or I don't know if they were them, but it's a known trick, is that you can actually, instead of doing sort of pipelining the traditional way, you can instead use continuations, where you pass in the next part of the pipeline explicitly, so that the middleware working on something will then in the end call the next function. It's actually called next, and it just calls it with the context, and then that will sort of trigger it, and then you can avoid a lot of these unnecessary wraps and unwraps. Actually, the other thing that you can get from this is that you can get tail call optimization. So the compiler can optimize these things, so you can get rid of loads and loads of unnecessary function calls. And the other third thing is, and we haven't talked about this, if you think of it as a continuation monad, it actually provides techniques which we haven't talked about, but you can look it up, which allows you to do early exit. So if you know that you are finished and there's no point in continuing with anything, then you can just return, and this saves, of course, a lot of CPU cycles and time. So that's a very useful feature of also using continuations. But using continuations, of course, adds a little bit of complexity, but it's not so bad, because you can sort of work around it. So here's the new functional pipeline, and where we're going to be using continuations, and we have the same HTTP context, as you can see. We have the same function result. So this is just a object or a record type. This is the async new context wrapped in an option. There's a function taking a context and returning a result. And now we're going to define a new type, which is the HTTP handler. And it's actually the same thing as HTTP func, except that we add a new HTTP func at the start. This is the next. This is the continuation that we have. So we're going to get a context. We're going to do everything we do. We're going to produce a result, and then we're going to call this HTTP func with that. Now, if you look carefully, of course, you will see that HTTP context to HTTP func result is just HTTP func, so you can actually write this handler as HTTP func to HTTP func. And now we can write this composition operator as HTTP handler to HTTP handler to HTTP handler, but it's actually just stitching these continuations nicely for us. So the implementation is quite simple. So here's a graphical representation of how this works, and this is actually from Microsoft's documentation for writing middleware for ASP.NET Core, and we see that we have a request coming in. So the web server will be sitting out here at the left hand side, and it has done all the processing, talking over the wire, and it's produced a context, which is this request. And it goes into middleware 1, it will do its stuff, add, remove, whatever it is doing, and then we'll call next, which calls middleware 2, and it will do its thing, and it call next, and then it will call the next one. And now happens something really nasty, because now, of course, all these functions are going to return. And you know, when we're doing function composition functionally, we know that, you know, it's a one-way pipe. You cannot touch things on the return, right? So that's why we have these pipe operators. We have these composition operators that we use because they hide the stitching and prevent us from doing bad things. Now, in ASP.NET Core, if you're going to do the object-oriented thing like for real, you actually have to call this next thing explicitly, and that means that after next returns, you can actually do stuff. And you can see here, more logic, more logic, more logic. So you can actually change things on the return. Now, this is an extremely bad idea. This is for a number of reasons. And it even says, this is actually from their documentation. So you can see, it says more logic in this graph. But if you read their documentation, they say, please don't do any more logic, because if you do, you're going to break things so badly. So there you go. So when working with this, think of it as a one-way pipeline, and we're going to be using this operator when composing things inside Giraffe, and then we don't even have the possibility to screw it up, because that operator will take care of the stitching and hide all the details. So this is a big topic, dependency injection. It's actually not completely irrelevant for functional programming, but we can usually get away with partial application and higher order functions and so on. For object-oriented programming, this is modern object-oriented programming. This is an important topic, and there are even whole books written on the subject, and big books on like 500 pages on just this topic. But the idea is pretty simple. What you have is you want to make a flexible library or a flexible object or a flexible function where you don't want to tie yourself down to a particular implementation. So you want the user of your system to provide the actual thing. Now, if we think in terms of, for example, list.map, it takes a higher order function. List.map doesn't know anything about what you intend to do with the data inside. It just provides you with this interface where you can give it a function which it will apply. So this is the same idea. This is the idea of dependency injection. Now, you don't necessarily want to have it on the command line or in the sort of arguments to your functions, because it might end up very, very long. So in ASP.NET Core, they have used a fairly advanced form of dependency injection, which we'll look at briefly, to configure things. And the way it works is that they have in principle a dictionary, where the key of the dictionary is the type of the thing that you put in there, right? I'll say that once more. The key to your dictionary is the type that you put in. So if I create, for example, a type that I call foo, I can add it to the dependency injection container, say, okay, add type foo, and here's an implementation of type foo into this container. And then at a later point, I can say, from container, fetch and fetch the thing that provides this type foo. Typically, these will be interfaces, so it would be an ifoo, and then I can get it back. I'll show you an example how this works. In practice, this is very easy, but this was one of the things that puzzled me very much in the beginning. So I will mention it a couple of times when we're looking at the demos. So, configuration, because we want to be able to build a flexible pipeline. We want to be able to build a system where we can say, okay, in this special case, do this and that and so on and so on. So we have a for the people who designed ASP.NET Core or Suave or any of these, it's really important that you can do anything with it, right? And the way ASP.NET Core has solved this stuff is that first in principle, we configure the web server. That's the really boring part. It's sort of, we'll see, but that's sort of a pretty much always the same boilerplate that you plug in. But then comes the processing pipeline and all the stuff that you want to put in there, all the middleware, all these processing functions that should do stuff to your request before you sort of give it to your application, or after it comes out from your application, before it goes to the user, like session management or authentication and static files and maybe some logging and what have you. So so the way this works is that they have created a interface which is called iApplication Builder to build this middleware pipeline, and then using the builder pattern, you essentially add stuff to it, and these will get then stitched together internally by passing these continuations from one to the other. Now the middleware that you put in needs some of it, not all, but some needs some configurations, and instead of having a static configuration or some specific form for it, they have chosen to configure it using dependency injection, which is clever because now you can make your middleware do all kinds of things by giving your own implementation of a particular interface. So you need to sometimes configure these things, and then you need to add these configurations to the dependency injection container. What happens really runtime is that when the middleware, some particular middleware starts, it will ask for the configuration which actually will do the work. So the middleware itself is tiny thin little thing, and most of the heavy lifting is done in whatever you put inside this configuration container. So it will ask for it, and if it doesn't find it, if you haven't provided it, the whole thing will crash, or it will do nothing, depending on. We never know. So this is one of the things that finding documentation for these things is not the easiest thing, I tell you. But there you go. Now, yes. So the way we can get these dependencies out. So we can. I mean, they can be accessed from the middleware, or we can access them in our codes. So is that we get this HTTP context, which I call CTX, and there's a method on it. We can say get service, and then I say what type my stuff, and I can get the object out that I had put in, and now I can use it. So this could be a JSON serializer, deserializer. It could be some authentication thing. It could be, who knows, a logger. You can put anything you like in there, really, that you might need at some point. Quite convenient, really, but slightly sort of mind-bending for your head. Now, the final thing before we go to the examples is Giraffe, and I've given you the link to Giraffe. There's really good documentation. Go and read it. I'm not going to go into any great detail about how Giraffe works or all the things you can do with it. It's great. There's loads of stuff to read about it. It's your task. But I'll show you how to use it. And I'll give you an idea of how it works. So, So without further ado, let's switch to Visual Studio Code. And I'm going to take a quick little break. All right. Sorry for the fan, it goes bonkers when I switch. Right, so what I've done here is that I have, in the previous lecture, we created a web app using Felice. But that came without the server. So I've used a different template in this case. It's called safe. You can just install it with .NET new -i safe.template. And then you can just do .NET new safe -- help. And I've created an app with using the Giraffe server. And then I've fixed things a little bit. So one thing I did was that I threw out all the client code from the safe template, and I copied the app we wrote in the previous lecture into this safe application instead. And then I've added some few dependencies and stuff. All of this is on GitHub under uselius/inf-3910-demos. So they will find it's called safe. So that you can go and look at the details. I won't go. I've also updated this web app somewhat, showing you how to deal with input boxes and things like that. I'm not going to go through the details today. You can go and download the code and see how things are done. But there are a few things that we should mention, because the Felice app we had didn't have a server. And now we want to couple this to the ASP.NET Giraffe enabled server that we have. So let's have a quick little look at how this template looks like. So there's a bunch of stuff, packet, build scripts, and so on. But the important thing is that under source we now have two projects, client and server, and then we have a shared folder that I'll get back to in a second. Now the client contains essentially just the same app we had. Here's the app, there's the interop for doing a JavaScript interop, and a little bit of this and that, and yeah, this is the same project that we looked at last time, except I've improved on it. Now let's have a look at then there's the server, and it's just one file, very simple little thing. But let's have a little recap of this Fable app. So here's the model. It contains a count, it contains a list of people, there's a sort, and now I've added a extra little field here, which is a new person, which is a person option. And this is because I've added the possibility to add new people to the table. What you won't see here is this person type, and that's because I have moved it into this shared folder and shared.fs file. And here's the counter defined, and here's the person. And the reason why this is that the client and the server need to agree on the data types that they send to each other. So when they communicate and take data and turn that into JSON and send it over the wire, they need to have the same idea of what that data is and how it should be wrapped and unwrapped, so that we can have it back to F# types. So they share it. So that's the purpose of this shared file. It's used both by the client and the server. Now, as you can see, the message type has grown quite considerably. There's now an init, which will receive a result of counter string. This is to initialize the initial model, and it only cares about the counter. There's the good old increment decrement. There's the load and the load handler, exactly the same as we had in the previous. And now there's a save. And of course there's the exception handler, there's the sort handler, and then there's a a bunch of messages for updating when creating a new person. In the Felice app that we did previously, we faked. We did everything. We did everything in a slightly complicated way because we sort of faked having a server, but instead we just decoded a text string, a hard-coded text string. But now we want to really call the server. So let's look at how this works. So this init is the initialization thing for the whole model, and we can look at that because it's simple. I define a function taking unit as an argument. I define a decoder automatically. This is the Thoth library, and I just say decode a string and expect it to contain a counter, and the counter of course is defined in here, and this is pretty much is just straight into the JSON. Will just become a curly bracket value equal colon and the value of the int. So there's like almost a one-to-one correspondence between F# record types and JSON, which is nice. Then I define a promise, which is a function which takes unit and a promise. And now instead of just faking this, I will use this fetch and say try get. And we can look at that. And it takes a URL, which in this case is API init. We'll look at that in a moment on the server side. And it takes a decoder, which is our decoder up here, and some optional things that we don't need. And it returns a promise of a result of a response. So that's a little bit of a mouthful. And now we have our model. Just set it up with defaults and then say command of promise either p, and this is exactly like we sort of faked it in the fable, so there's no difference. Now this will then, when this promise finishes, it will trigger this init message, which will get hit by this one, which will then in the update loop call handle init. And we will match because this one creates a result. The promise is now gone. Now we just have a result. And we can say, okay, if OK counter, then we'll set the count value to that value. And there's nothing more to do. Otherwise, we print an error. I also have a little example here of how to save or how to post data to the server. So this was how to get data from the server, but now we have I'll also show you how to post data to the server, and then we'll look at the server side how we receive that data and process it. So this is almost the same. Say person takes the model, it generates a decoder for the person. This is not strictly necessary, but when we post, the web server will reply, and now I made the reply be a person. It could just be a unit or string or whatever, but I decided you post a person to it, and it will ping pong it back to you. So that's why this decodes a person. I could have done whatever there. So now I look at this model new person and see if this model new person is some data. I create a promise. Instead of try get, I say try post. I give it the URL. I give it the data to post, and this will automatically be serialized to JSON. So I don't have to do any kind of by hand any encoder. I just give it the data and it will do it for me. And then I have to specify to it the decoder for how it should decode things. And then I say command or promise either, and it will call the save handler and it will do the logic. And the rest is sort of there's not really so much more to say. Here's the fetch people that we had in the previous example. It will do, instead of just it will do try get on the API people and decode that for us, and rest is pretty much the same. I also added some nice graphics, and I'll demo you some just to make things a little bit nicer. And one of the things that I have done, because when writing these writing HTML with F# you quickly end up with really long functions, and then it's good to remember that they can be split up because these are just functions, so you can easily split them up in smaller functions and pieces that are both reusable and makes things more readable. So if we go down to the end here and look at it, we see that I'll call it render here instead of view. Basically the main view here is a container. It contains a section with a counter view, it contains a section with a title, there's an add person view, and if there are people, then it will make a box and show a people's view and a charts view. So this is pretty so easy to understand, and then those are just functions that have been defined up here. So that's the client, and there's not so much more to say about it. So let's go to the server and see how that looks. And let's start from down here and see how this fits with this ASP.NET view of things. So the first thing we have down here is web host. And we can look at that and we'll see that, okay, it's a type, it's a class, it has 3 static members, create, default, builder, start, and start with. And I don't know what those do, except that create default builder will return a web host builder object. You got to love these object-oriented programmers. And then we can start putting things on top of that. Use web root. So that basically says where in the file system should this system run. Where should it look for default content. And then comes an important one, configure and configure app. And this is actually where you plug in your middleware pipeline. This is the one. This is the most important line here, really. Now it looks kind of nasty because of course this is done for C#. So in F# we would just give it a function. This would be a higher order function. But in object-oriented speak, this is a action which is a delegate of a application builder something, and then whatever. We don't have to care. The only thing is that we need to know is how to write this function here. The next line is also important. It says here's the thing that sticks stuff inside this dependency injection container. So this is the dependency injection service configuration spot. And then which address should we listen on? Should it be HTTP, HTTPS, and what port, and so on? And then we say build to sort of close up this builder object, and then we run it. And so this line here starts your web application. So this is really just the, if we go back to this mental picture of this pipeline, this is the HTTPD part. And set up like this will run Kestrel. I could have an explicit use Kestrel here. There's also a use IIS if you need to run it on Microsoft Internet Information Server, God forbid. So, okay, so let's have a look at this configure app. As you can see, it's up here. It takes an iApplication Builder object, and I say use default files. It's that you pretty much always do. Use static files. This means that it will, if it doesn't really figure out what to do, it will try to look in the folder where it's running if it finds the file there, and then it switches to Giraffe. Sorry, there was a little bit of disturbance there. Yes, use static files, and then say use Giraffe, and we give it a web app. We'll look at that in a second. Now, this is where we dispatch to Giraffe, and Giraffe is basically to set up in such a way that it's always the last thing in this pipeline. So if you put anything after Giraffe, it will never get called, because Giraffe won't call the next method for you unless you hack things yourself, which you shouldn't. Right, so then let's have a look at, we could actually have a look at what else is available here. So we can say use, well, here you can add use authentication, certificate forwarding, cookie policies, CORS for cross-origin resource sharing, endpoints for I don't know what that does even. A lot of this stuff is we don't really need when we switch over to Giraffe, and we don't care. But things like CORS and authentication, authorization, very, very useful things to have. And one of the important things is here, don't roll your own. It's hard. And if you make the tiniest little mistake, somebody will break your application. So when it comes to authentication or authorization, use the stuff that you find in the ASP.NET Core pipeline. There is 30 years and 40 years of experience with creating secure software there. Don't try to do it yourself. You will burn yourself. Guaranteed. Like, it's amazing how easy it is to make a security hole. So, end of rant. So dependency injection. Let's look at the dependency injection just briefly and see how that works. So that's a function called configure services. It takes a service collection, which is essentially just a glorified dictionary, and then we say services add Giraffe. And this might be a little bit, at least to me, this is kind of strange, because add Giraffe doesn't really take any arguments, but it's added as a service. For some reason you might want to, I don't know why you would ever want to be pulling it out from the dependency injection container, but maybe there's a use case for it. I don't know. I would expect Giraffe to set up everything for me and then just forget about it. Here's an interesting add singleton. And then we add a type of serialization JSON JSON serializer, which is actually used by Giraffe. And then up here I choose to use the JSON serializer. Of course, these things need to fit together, so you can't just put in any odd JSON thing there. They need to implement these right interfaces, otherwise things will not work. But that's, so this is just boilerplate. But there's a whole bunch of other things that you can add here. So you can say services, add anti-forgery, and again, authentication with authentication options. You can configure authentication, authorization, and so on and so on and so on. There's a whole bunch of stuff. Logging, memory caches, and so on. So there's plenty of stuff to explore here. But we're going to keep things really, really simple. Now, next stage of looking at Giraffe is looking at Giraffe and looking at this web app. And then we can go up to web app. And then we see, here's a web app. It takes, and you can see, it takes a HTTP func, HTTP context, and a func result. Now, if you remember, I have a really good memory, you will see that this is nothing but an HTTP handler. And since I have 3 APIs, I have used a function called choose, and we can look at that. And we can see that it takes a list of HTTP handlers, a next function, which is an HTTP func, and it produces a HTTP func. Okay, so what this will do is that it will try various routes, and if it fails, it will try the next and the next and the next until it falls off the end. And in this case, I don't have any particular, I haven't said what happens if it falls off the end, so it will just go to the static file handler and see if it works. And if it doesn't work, you will just get back nothing. So there's no error handling here, or any 404 or anything. Then there's a function called route, and it takes a path. Again, takes the next continuation, it takes the context, and it produces a func result. So it's again a HTTP handler. And here's the string. So it says if. So what this will do is that if the request coming in is asking for API init, it should continue the pipeline to handle init. And here's the bind operator. We can see, oops, it takes HTTP handler and another HTTP handler and produces an HTTP handler, except that it's expanded, so it looks like really complicated, but it's not. So this is just pipelining. Take this stuff, goes into that stuff, and the result of this, which is just doing nothing, it just sort of filters things, goes into handle init. And handle init takes two arguments, the continuation and the context, and returns a task of option of HTTP context. Now it's returning a task and not an async, because task is the C# native thing. It's more or less the same as async. It's just that it's the C# version of it, again for performance reasons. So we can go up and look at handle init. Here's the function. Next, HTTP func, the context. We create the task. We say that, okay, counter should have the value 42, and then I say return, and I call this function JSON, which will take some data, F# type, whatever it is, serialize it to JSON, and send it over the wire to the client. And of course, I have to pass in the next and the context to the JSON function. Then I have added an extra filter. So this choose, it will just pick whatever. But now I've added an extra little thing here for the next one, just for the demo. It's a get. So it will check. As you can see, it takes a HTTP handler. So it will check the context and see, is this a get request? If it's not, it will just skip everything here and go to the next and see if it's a post request. Typically what you would have is that you would say choose, and then you would say get, and then you would have a pipeline into a new choose, and then you would have all your get handlers in a separate choose, and then you would have all your post and your option and your delete and update and so on. But now I just made it sort of the easy way here. So this filters on the type of request. So this up here is unfiltered. I could have said get like this, since I know that this is will only respond to get requests. Get people. So I've actually added a little bit of persistence here. So what will happen here is that as this handle get people gets called, it will read a data file, which I have defined up here. A file in the file system called people.json. It will read the contents of that file every single time that this endpoint is called. It will do a JSON decoder on it, so it will decode it into JSON as a list of persons. And if that all goes well, it will turn it into JSON and send it over the wire. If it's an error, it will return a bad request 400 error with an error message to the client. So it's well behaved. But then we have a post. So this will actually receive some data. So we're going to look at add handle person, because that's a little bit more involved. In add handle person, we read the data file again, decode it from text to F#, and then that's what we do here. So I get if everything goes well, I get a list of persons. Otherwise, I get an empty list. And then I handle the post request, and that can actually throw an exception at me. So I have to put it inside a try block. And by using this bind JSON async, I can get the data from the request, and then I can encode that. So I can add the new data to this list of people, and I encode it and I write it to a text file. So now I've saved the new person that came into the text file, and then I just return the same person that was sent to me. This is sort of the ping pong part I talked about earlier. And that's pretty much it. So this is a quick breakneck speed walkthrough of a simple web server. Now let's have a quick look at how this actually looks like. This whole application that we've been looking at, and let me reload it just so that we see. All right, so now you see that the strike counter here actually hit init, and it returned 42. So if we go back to here, we can see handle init sets the value to 42 and sends it over the wire back to our web browser. And we can still increment and decrement, and none of these will trigger any network traffic. Now you can see here I've added these input boxes for adding new people, but I can now press load, and it will fetch people off the server and then present them nicely in a table. I also added age and height, so I could do some nice graphs. So just to show you some nice graphing libraries, I've added a little bit of graphics here, and the cool thing is that, of course, if I now sort on first, you can see how the graphs respond to sorting. Can add. So let's add some stuff here. 37, height, he's a tall guy, 201, save. So now we got there he is, got added to the list. And we can actually reload the whole application now, and we should still have Barnabas Plumlund in there, yeah. And actually, if we go back to the server, and we can go look at this people.json, you can see that now there's a Barnabas Plumlund entry in the JSON file. And if we go back and add foo bar raboof age 19 and height 186, save, and we can go back, and you see that here is foobar raboof has appeared in the list. So that's sort of it, and this is it. For those of you who have followed all the lectures, this is all you need for the obligs and for the exam. There won't be anything more. For those of you who missed the functors, applicatives, and monads and monoids, I will put those lectures out quite soon. I will do a few small bonus episodes during tomorrow, I hope. The next one will be on persistence. It hasn't really anything to do with F#. I will talk a little bit about databases and how we can deal with databases nicely, because I think I hate databases, but they are kind of useful, and it's sort of essential if you want to be able to do real life software. So we need to be able to deal with databases somehow, and I'll talk a little bit about various ways of dealing with databases. I will also try to put out a lecture on short little lecture on testing. Standard unit tests, very little, and a little bit on property-based testing, which is sort of specific to functional programming. But now we're pretty much in gold. So if you don't care, you don't have to watch anything anymore. This is it. This is the final one. So thank you so much, and until tomorrow.